So, hey folks, this is me, Vishwa Stan. I'm the host of this webinar. This is a Kubernetes 101 series. A lot of times, when we go back to the basics, we have to look back at some things which are already rigged up in the market, and we have to learn from it over a course of time. And I think Anish has been one of those versatile engineers that I've ever seen who can really help you get that inclusive feeling of, you know what, there is something magical about technology. Let's go and build it up right now. And I think the challenge is all about the technology. The challenge is all about people. The challenge is all about the skills, but Kubernetes can be mastered over a course of time. I think folks like Anish can really give you a lot and lot of insight about the Kubernetes space and the evolution of this space over a course of time. And over to you, Anish. The stage is yours.
Thank you, Vishwas, for kind words. Actually, I may not be that great, but yes, I'll try to share whatever experience I have around the topic that is Kubernetes. And uh, uh, moving forward, so let's try and understand what are we trying to cover today. So we'll start with basics, what Kubernetes is, what are the storage, what are the service discovery, then why do we need Kubernetes, and different subtopics under that, and then finally we'll try to understand a new technology which helps us better the Kubernetes implementation. So this is the agenda for today, and jumping into what Kubernetes is. So for folks who are new to the Kubernetes world, a brief background. Kubernetes is a container orchestration tool which was open sourced by Google way back in uh, early 2010, and it has been fairly good technology which industry is adopting towards. And what containers would be, I believe most of us might have heard about Docker, Podman, so on and so forth. So container is nothing but scaled down version of your virtual machine, which only has the prerequisite required for running your specific application rather than plugging in different tools like Microsoft Word, so on and so forth, which may not be relevant or required for running your application. And what Kubernetes does is extends the capability, does the container orchestration at scale. So that what Kubernetes is, and let's try and understand it from the pictorial view how Kubernetes is architected and what component exists. So first thing first, the core of Kubernetes would be control plane. If we have to say it in a layman's term, it would be the heart of Kubernetes, which does the heavy lifting under the hood, and control plane has multiple components involved in it. The first one being Kubernetes Controller Manager and Kube Control Manager. What Controller Manager does, as the name specify, it is primarily a utility within Kubernetes ecosystem which manages the end-to-end functioning of Kubernetes, ensures that whatever is required by a Kubernetes system is up and running, and this is the primary responsibility of controller manager. Then the next component would be scheduler. Since I talked about orchestrating your containerized workload, how does Kubernetes understand which workload needs to be orchestrated or deployed or scaled out? So that is a job of Kubernetes. Kube scheduler, the third part is kubeproxy, may not be relevant in control plane's perspective, but if there are multiple cases, you could have Kubernetes set up with a single node, or you could have multi-node setup with multi-master. So control plane could be considered a master node which manages your end-to-end functioning of Kubernetes cluster. Kubeproxy is relevant for the nodes which provides you end-to-end capability of networking and ensures that right services could be reached. The next component would be etcd, which is primarily a storage layer, distributed data storage layer, which holds different configuration pertaining to Kubernetes and ensure these configurations are utilized in the right fashion to have a smooth functioning of Kubernetes. Then the final aspect in the control plane would be Kube API server. Kube API server is a API layer which helps nodes communicate with the internals or the other services which are not exposed to external world. So Kube API server helps node provision right kind of workloads, scale up, scale down, so on and so forth. And there is right kind of connectivity between all these components. Then the key aspect would be system services, which are not exposed to external world, which would be container runtime. What container runtime would be? Since we are talking about deploying your containerized workload or orchestrating them, we need to have a underlying container solution. So Docker is one of the container solution, Rocket is another one, Podman is another one. So there are multiple containerization solution, and Kubernetes, with this implementation, you can choose the right container solution which is required for your implementation. And finally, kubelet. Kubelet again is relevant for nodes, but it is available here. Reason being, there is a possibility wherein a master can also play a node or a worker responsibility. So this was all about control plane or master setup. How does the worker perform? So that is the next aspect. So node is nothing but a worker which does the or heavy lifting or orchestrates your containerized workload. And what are the different components involved in your node? So the basic basic implementation within Kubernetes would be a pod. What exactly a pod is? When if people with Docker experience may find it difficult, but pod is a superset of your containers. A a pod could hold multiple containers or multiple workloads, but if we have to think about it, pod is a single unit of workload which performs single action. It could host multiple containers within it, so on and so forth. So pod is one of the key components within your node. Then your kube proxy, we spoke about it. It is critical for ensuring the connectivity between different pods and different nodes. Then you have your different system services similar to your control plane, wherein your container runtime is part of your worker setup as well. And kubelet is your worker node, which does the heavy lifting of ensuring the worker node is healthy and is up. And we spoke about Kube API server. So in order to perform different action on your worker node, there is a connectivity between Kube API server and kubelet. Kube API server can pass on the right information to the worker nodes to perform the right actions like scale up, scale down, uh, rolling upgrades, and so on and so forth. How does the external world or developer interact? So, Cube API server is the key entry point for a developer to interact with your Kubernetes cluster, and the developers would perform kubectl operations to do the right desired activity, and these are then passed on to the worker node to perform the right actions. And how does the end user interact? So end user directly interacts with the kube proxy, which does the magic of identifying which is the right service that needs to be invoked or the request needs to be passed to which service. So that kind of heavy lifting or identification is performed, and end user gets the desired result. And when we talk about nodes, there could be multiple nodes similar to multiple control plane. That could be dependent on the architecture or the enterprise requirement. So on a high level, this is high level view of how Kubernetes has been architected and gets deployed under the hood. The next topic which I wanted to bring on to the discussion table was storage. Since most of us know containers are of ephemeral nature, how do we ensure that persistence could be achieved? I'll try to give that with an example. Let's say we need to store some user data for long term. And if we have a service which gets deployed as part of container, uh, the container would, the moment it gets decommissioned or recommissioned, the state of that container gets destroyed and data around that service would also get deleted. In order to ensure that that data can exist beyond the life cycle of the container or the pod, concept of storage comes into picture, wherein there are two concepts like persistent volume and persistent volume claim. Persistent volume is attaching or allocating some uh, storage to from your underlying storage for a specific service, and that service or the storage could be attached to a pod or a workload. And how is that achieved? Let's have a look at it. So, uh, the bare minimum requirement for persistent volume claim is pod needs to provision or request that kind of storage. So, uh, let's assume we have underlying storage. It could be SAN, NAS, or any storage service like AWS storage service, GCP storage service, or there are different players in this space like Pure Storage, which offers great capabilities around the storage service. So you need to define the storage space, then you need to claim what kind of storage requirement is there, so on and so forth, and what storage class is required. Based on this definition of your manifest, Kubernetes automatically identifies the persistent volume and attaches it to the pod which requested for the storage. So this is plain and simple way of achieving persistence in your Kubernetes world. Moving on from storage, one of the key concepts or areas or questions which might come into newbies' mind is, since Kubernetes is a system which is made up of different services or components, how can we identify individual service within distributed Kubernetes setup? So this is where it this is how it is achieved. Primarily, what Kubernetes does is it leverages the concept of labels and annotations to actually define your service names, and based on the request which is coming in, the labels helps Kubernetes understand which is the right service, and based on this, it sends the request to the right pod or workload. So this on your screen you see the request is coming for app called Nginx and environment called prod, and in the Kubernetes environment or cluster you have multiple pods deployed with different labels: app Nginx prod, app MySQL environment. So based on the labels which matches exactly to the request, then only the service is sent to those services, otherwise it is ignored. So we had a brief high level overview of what Kubernetes is, how the storage works, and how service discovery happens under the hood. Now we need to understand why Kubernetes. So people coming from with decades of experience or more than that, they must have heard about monolith implementation, wherein everything was bundled as a package in a single virtual machine, and all the services were accessible from a single code base. Now, let me try to explain this with an example. Let's take the example of a banking service or net banking service, wherein you have different services like banking operations, then your credit card, your mutual fund, so on and so forth. In early days, what was the situation was all these services, banking, credit card, mutual funds, so on and so forth, was bundled as a single package and was deployed onto the target environment. And depending on what kind of request was coming in, the right service was getting invoked. So that is what monolith was. Now, in order to move from monolith, uh, monolith had its own set of challenges. If single change was requested in banking service, uh, it was not feasible to roll out the smallest changes in quicker turnaround time, because end-to-end service, banking, credit card, mutual funds, everything need had to go under a stringent regression suit. Unless the smallest change was certified, it could not see the light of production. So, in order to overcome these challenges, uh, people from the industry came up with good strategy or a framework which tried to decouple individual services like banking as one service, a credit card as another service, mutual fund as another service, and those gets deployed as individual services, and the request would go into requested service, and that is on a high level or in a layman's term the concept of microservices, breaking down a monolith application into smaller functionality which does the job and helps achieve the quicker rollout to production. So since industry is already adopting microservices, I'll try to help you understand the Gartner study, which identified that in 2020 the microservices industry im- spending was around 810 million US dollars, and it is predicted to grow to 2.8 billion US dollars by 2027, which is a close to 3.2x jump. So, looking at this trend, we see most of the age old implementations are moving or deciding to break down their monolith implementation and converting them into microservices, which is evident from this slide. Now, since industry is moving towards microservices implementation, how do we host these microservices? This is one of the big question. There could be multiple solutions or multiple target environment which can help us deploy these microservices. Let's have a look at what options do we have. So there are primarily three categorization of industry Kubernetes is a concept of cloud. Uh, Linked to your hyperscaler is another aspect. But for today's discussion, we'll focus only on Kubernetes as a target platform. Now, with knowing about what are the target platforms, um, with Kubernetes, we know Kubernetes as a solution. How can we be sure that it would continue to run, be functional, or will be adopted 5 years or 10 years down the line and it would perform the s- standard implementation? That is where cloud native computing foundation comes into picture, which is a organization or umbrella which manages different products, which helps transform the cloud native solution or host the cloud native solution. So Kubernetes is part of CNCF, and looking at the right side of the screen, you'll see there are different Kubernetes certified CNCF distribution, hosted services, installers, so on and so forth. And since CNCF is mandating the right standards, Kubernetes is adopting, and we can be certain that a standardized flavor of Kubernetes is available for implementation 5 years, 10 years, or maybe more than that, and would be in mainstream. Now, there are two aspects. Kubernetes can be on-premise deployment and a cloud deployment. Looking at the screen, we see there are multiple, or Kubernetes is well adopted by the hyperscaler. AWS has its own service, Microsoft Azure, IBM Cloud, Google Cloud. These are not the only hyperscaler which have their services around Kubernetes. Each and every hyperscaler has its own service, and that is how we can leverage the Kubernetes service. Now, the question would come into your mind: why hyperscaler service? Why not on-premise service? Because these are two valid use cases. Depending on enterprise requirement, Kubernetes could be a on-premise deployment, or it could be a hyperscaler deployment. But in order to decide which is the right part to go forward with, we can always uh, understand the underlying challenges with. both the two deployments. So, if we talk about hyperscaler Kubernetes services, one of the key aspects which you as a owner you do not have control is the control plane aspect. The control plane is managed by the hyperscaler, which leaves you with lesser overhead of managing your Kubernetes cluster. Whereas if we look at the on-premise side, the end-to-end implementation is a enterprise overhead, and they need to have the right competency, skills, so on and so forth to manage their Kubernetes cluster. So these are two options. But looking at the industry trend, uh, based on my past experience and implementation, I can say enterprises are not just sticking to hyperscaler or to on-premise. There is a hybrid Kubernetes implementation. I have worked with an implementation wherein certain non-production workloads are on Kubernetes hyperscaler, and production workload is on your on-premise setup. And one of the key consideration for deciding was hyperscalers, uh, even though they have GDPR compliance and other compliance, but enterprises are not really comfortable pushing their production data into s- some external vendors' purview. So that is one of the challenges why enterprises are leveraging the hybrid Kubernetes deployment approach. And talking about the other implementation, which is purely a private cloud setup, but it has multiple flavors. So there are two different data centers wherein Kubernetes is deployed, and there are two different flavors of Kubernetes that it's is deployed. So there are different challenges around managing your Kubernetes setup. So understanding that problem statement, how can we achieve that? So let's try and understand what are the different challenges with Kubernetes adoption. So Canonical did a survey of over 1,200 Kubernetes enterprises, and based on their survey, these were the top challenges which were notified by the enterprises. Competency is one of the key challenges, organizational IT structure, so on and so forth. Look, I am not going to deep dive into individual challenges, but let's try and focus upon key challenges which are highlighted in your green rectangles. Competency is one of the key challenges. Security compliance is one of the other concern. Then networking requirement, which needs individuals or enterprises to build their own networking layer by implementing the right firewalls or ingress rules, ingress controllers, so on and so forth. Multi-cluster management. So I spoke about a situation wherein you have hybrid Kubernetes setup, then monitoring and observability, inefficient day-to-day operations. So these are the key challenges based on which I would try to jump into one of the management tools which can help us achieve the management aspect. So looking at these high level challenges, uh, do we think an industry did not foresee these challenges cropping up with the Kubernetes implementation? Yes, the industry foresaw these challenges, and based on that, they came up with their own individual products to help mitigate these challenges, and looking at what are the different management services which can help us manage or overcome the challenges which were highlighted in the previous slide. So Red Hat did a survey of Um, Polycloud Kubernetes deployment, and this is their result. So there are different products like VMware Tanzu, Microsoft Azure Arc, Google Anthos, AWS Outpost, Red Hat Advanced Cluster Management. So these are only handful of tools which I have mentioned. If I have to talk about others, Rancher, Platform 9, so on and so forth, are other tools which can help us manage hybrid Kubernetes clusters. And what are the benefits of this? We'll talk about it with understanding how Google Anthos provides the capabilities. And when we are talking about Kubernetes, one thing which we need to understand is latest way of working. So application development or deployment is not similar to what how it was done a decade ago or maybe earlier than that. Now, with introduction of DevSecOps, so DevSecOps, I'll come to this point in subsequent slide, but yes. So this is different tools which can help us manage hybrid Kubernetes clusters. So let's try and understand what Anthos is. On similar lines to what control plane for Kubernetes, Anthos also has a common control plane with multiple components, and I'll talk about the DevSecOps aspect in this slide. So, Anthos uh, primarily is a Google Cloud product which ensures that it's once a Kubernetes cluster is added under its management, it does automatic updates, rollouts, so on and so forth on the managed clusters within its purview. So, first thing first, uh, what Anthos does is it can manage your Kubernetes cluster deployed in Google Cloud. If we take a step back and think about CNCF, Cloud Native Computing Foundation, they have set the standards for Kubernetes. With those standards, all the different flavors of Kubernetes has right kind similar setup which helps different products like Anthos, Azure Arc, so on and so forth manage these Kubernetes cluster on different environments or different data center or hyperscaler. So this layer talks about what is your target environment. Then there is two key components within Anthos. One is observe, another is manage. I'll observe does the monitoring and logging. So this is aggregation of your telemetry data from your infrastructure as well as application code. And manage layer does the auto rollout of upgrades, scaling up, so on and so forth, which can be managed through different utilities like Anthos UI, KRM API, so on and so forth. So this is on high level the Anthos components, but what do we have in between? So if we recollect, I spoke about DevSecOps. So DevSecOps, let me try to explain that concept. DevSecOps is a broad term which anticipates or the philosophy talks about bringing in development and operations team together. But what does that mean? So if we have to break it down further, there are primarily three areas within DevSecOps. First one would be platform engineering, which deals with and or ensures that right infrastructure is provisioned so that subsequent workloads could be deployed. And uh, by provisioning, it also requires scaling up, scaling down, optimization. So, DevSecOps always talks about automating your manual processes, and infrastructure provisioning or platform engineering aspect takes care of automation of your infrastructure provisioning. Then comes the application part, which it talks about doing the feature releases, feature development, so on and so forth. But if the feature cannot be tested the moment it is ready, it adds to the delay and has a effect or brings down the profitability. So automation is also required there. So when we talk about application automation, it always talk about automatic build, package, and deploy. So the moment there is a check-in in your source code management, right kind of tools like Jenkins, Circle CI, so on and so forth can be leveraged to automatically build your application, package it, and ensure that it goes into the production. So features can be released faster. And then the third aspect is SRE. SRE is site reliability engineering. Uh, People have been doing this for ages, but this is a new term which ensures that both your infrastructure as well as application is always up and meets the SLA, SLO, SLI, which are defined by the enterprise. So this is on a high level what DevSecOps is. Now let me break it down how Anthos is trying to achieve that. So the first aspect would be platform engineering. So here we have four different l- layers: infrastructure management, cluster management, service management, and policy enforcement. So from my perspective, these are all aspects of platform engineering folks who carry out the automation. So, infrastructure management, uh, Anthos suggest Anthos GKE for infrastructure management so that you have a streamlined Kubernetes setup, but they are not just restricting Anthos GKE. You could have your own flavor of Kubernetes, which still can be managed by Anthos. Then cluster management, Anthos GKE, Ingress for Anthos. For service management, uh, Anthos Service Mesh. And why service mesh is required? We need to aggregate the telemetry information coming in from your underlying infrastructure to take the real time decisions in order to achieve the SLI, SLO defined at the enterprise level. And then finally, aspect would be policy enforcement. Uh, and this would be very evident or prominent in hybrid Kubernetes cluster scenario. If you have a single Kubernetes cluster, uh, it can be achieved seamlessly, but when you have distributed Kubernetes cluster, having the right kind of policy enforced on all the cluster becomes very critical, and this layer helps achieve that using Anthos config management and those enterprise data protection, so on and so forth. So this was on the platform engineering side. Okay, my bad. Sorry. So what Anthos does is it continuously with the right monitoring and observability services which are part of the cloud, they start aggregating all the information by deploying the right agents in the underlying infrastructure to aggregate the telemetry information, and this is stored in the monitoring uh, tool. Uh, Once this information is aggregated, uh, this can be passed on. Okay. This information could be passed on to take the real-time decision. So I'll try to explain this with an example. Let's say one of your Kubernetes cluster is running low on memory, uh, and there is a need for adding one more node. It could be done seamlessly through your infrastructure automation if you have the right rules in place. But if you automate everything, one of the challenges would be in case of DDoS attack, your Kubernetes cluster may have unwanted load which is spiking up your memory, and in order to cater that, if Kubernetes is scaling up, there is a cost involved. So if you have to have the right mechanism in place or SRE come into picture, you can pass on this information to SRE folks who can take the real-time decision by doing the right root cause analysis and scale up the cluster if there is a need. And once these GUI-based application or APIs are invoked, you can actually do the real-time changes in the underlying tower. So this was all about your platform engineering side. Now let's talk about how Anthos helps doing the application automation. Uh, Build, package, and deploy. So it is straightforward. Anthos doesn't have right tools and services to do that. It could be based on enterprise decision whether they want to leverage all the services which are s- provided by Anthos, or they could leverage their own way of working for achieving it. So what Anthos proposes is application development happens be it on their developer's laptop, or you could spin up a virtual development environment in cloud, and that can be leveraged as your application development environment. And application deployment, these are different tools which can help us achieve that. Google Cloud Marketplace can be leveraged to utilize Scott's product like WordPress, so on and so forth. Migrate for Anthos can help achieve transform your application workload into Google Cloud, Cloud Run, so on and so forth. As far as build, automated build and deployment is concerned, there are different tools like GitLab, Circle CI, Jenkins, so on and so forth, Spinnaker, which can be leveraged to achieve this. So, in a nutshell, this is a high level common control plane which does the magic of doing the right things in the right place for in the Anthos ecosystem. Moving on, one of the key concepts with Kubernetes is service mesh. Service mesh, if folks you are not aware about it, mesh is a capability which helps us uh, achieve the greater security with MTLS implementation, service discovery, so on and so forth, for which a developer might have to do extra bit of coding. So one, I'll try to explain this with an example. Uh, One of the key concept would be, okay, I am losing my thoughts here. Uh, yeah. One of the key challenge is service availability. If one of the services is not available, we as a developer we need to define right kind of implementation within our application to respond back with the right response 404, 302, so on and so forth. But what service mesh does is it has these kind of capabilities built into the service mesh. So if we look at it, Istio is one of the Google product which provides the service mesh capability. Linkerd has its own service mesh implementation, so on and so forth, which does the heavy lifting of service discovery, enhancing your security, aggregation of your APM telemetry data using implementation like Kiali, Grafana, Prometheus, so on and so forth, which does the additional heavy lifting, which as a developer you may not have to worry about, and you can just focus on the business, enhancing the business capabilities rather than looking into the technical aspects. So Anthos Service Mesh offers is baked into Anthos. If we go back to the previous slide, we talk about aggregation of telemetry data. So Anthos Service Mesh does these kind of heavy lifting for Anthos, and that is how the right kind of information can be provided to folks working under the SRE umbrella, and they can do the real time adjustment in the cluster. Then one of the key aspect is uh, policy management or streamlined hybrid Kubernetes setup. So this is achieved with the concept of GitOps, wherein all the configuration gets pushed into your source code management. It could be GitHub, GitLab, so on and so forth. And with right any change in your policies, these get propagated to the target Kubernetes cluster using Anthos config management. So that is about Anthos. And before wrapping up, I wanted to talk about one of the app modernization strategy which Google is proposing, uh, leveraging the Anthos services. So there are four towers within app modernization strategy. The first one could be lift and modernize to container, migrate to VMs, containerize in CI/CD, and refactor to microservices. So these are four different areas we need to consider when we are thinking about a transformation journey. Uh, And this is the existing application. So existing application could have different setups. So we'll talk about it. The first thing which we think about is existing application, if it can be directly refactored to microservices, that is the happy path. But does all the implementation follow this happy path? No. And how do we handle the different deviation from the happy path? So let's talk about it. So if the existing application is written in modern frameworks. By modern frameworks, it could consider your uh, Java implementation using Spring Boot or your Angular implementation. These can be considered as modern frameworks, and these can be directly containerized. Uh, Leverage the Anthos CI/CD. If the application is not written in modern framework, then what are different aspects? So The next aspect is packaged application. So SAP, Oracle, these are packaged application which needs to be thought about. So how do we do that? So Anthos suggests is we containerize with Migrate, which is a service offered by Google, and dip, move it into container, and gradually we containerize it and plug it into the CI/CD pipeline. Then there is brownfield applications, which cannot be brownfield applications would be a lot of dependencies between the applications, so those cannot be containerized. So uh, one of the ways of modernizing it would be utilize the migrate functionality and deploy it as a virtual machine workload, and then uh, plan the refactoring in stages, which can help us modernize the existing brownfield application. And then the final one would be legacy backends. By legacy backends, I would say mainframes, which cannot be modernized. So what Anthos or Google suggests is you migrate it as a virtual machine workload and put it under Anthos purview to manage it for regular updates. So this is what I had on my mind to be discussed for today's talk. Open for questions.